All right, guys, so we're going to be going over SQL basics and SQL queries. Let's start with SQL basics. I'm going to open that up. I'm going to fork that over. All right, that should take a second or two. So here we're given a general structure that we want to create, and we just need to create tables and then insert data. So we have one table created for us. We need to create the rest, but they kind of detail what we need in these tables right here. So let's kind of do this together. I'm going to do a git clone. I don't know if I copied that URL. Copy that. Okay, so SQL basics, clone that down, code that up. All right, so that took a little longer than I would have thought. Now there's VS Code. Drop that over here, and let's get to it. Okay, so create schema. This is where we're going to write our schema. So it looks like, again, they created one table for us, which is the students table. It looks like the students table has an ID. This is the primary key. Again, the unique way to identify each record. We have a first name, last name, birth dates, which is a date field, and an address ID. All right, so we need to create the rest of the tables here. So let's kind of do that. They give us a general structure we could go with, so we don't have to really decide too much here. Looks like we have an addresses table, so I'm gonna try to copy this. All right, so we need to create an addresses table. These are the fields. Let's get that going. All right, so first I'm just gonna do a drop table if exists. The reason we do this is because if we run this schema multiple times without these statements, it's gonna try to recreate the same table, and you get an error in running the schema again. So the drop table will just say drop the table if it exists, and then we can recreate it so that we don't get any errors. So if table exists, this will be called addresses. All right, so let's create our table. We're gonna name it addresses. And then we wanna give it some fields. So ID is usually what we'll call our identifier field. Make that serial, primary key. And just to review, the serial keyword will be basically an auto-generating ID. So we don't need to necessarily specify the ID. It'll be incremented and automatically created for us. That's kind of nice. So we don't have to worry about like what the next ID will be. Joseph Banks, you have a question?
Yeah, I was wondering about the serial. Does it matter where within the code you start and stop that? So if we start it there, we run, I don't know, 50 lines of code and we enter another serial, will it ever consider it a new start?
So each table for its primary key is going to have like only one field will have the serial keyword. You're not going to have like serial on multiple keys. But this is unique to each table. So this table is going to start at some ID, and this field will start incrementing for this table only. That has no impact on which IDs that my student table uses. So we might have ID 7 here and ID 7 here. Those are totally independent.
Okay, that answered it. Thank you.
Cool. All right, let's get this going. So line 1, that's probably a varchar. I'm not sure what the limit is on valid addresses. Let's just say 255. Like they have some long street names. Was there another hand raised? All right.
Yes, I just had a quick question about, I guess, the syntax and word choices, because I guess serial, they showed us something different yesterday that can accomplish the same thing. Would you care? Yeah, would you care which one we use, or is it just we just choose as we like? There were other verbiages yesterday that were different.
Yeah, I personally would not care. I think Jake and Jack might have mentioned this might be outdated. So there's an as identity. We could try to Google that as identity Postgres. So I think they probably use generated as identity. I cannot say what the difference is between using this and serial. I prefer serial just because it's shorter to write, as in it's easier for me to remember. I want to say there's probably not a huge difference, so I think you'd use either. I know I'm kind of being wishy-washy there, but I'm just gonna go with serial. But they should accomplish the same thing. There might be differences. I assume Google's gonna know better than I will. So I'll kind of leave that up to Google to tell you what the difference might be there. All right, so let's keep this going. We have states. There aren't very long states. Let's make that 32. I'm just picking random numbers. And then we have zip code. I'm gonna make that a varchar. I think zip codes have 5 digits, but they could also have that dash and 4 extra digits that are more specific. So let's make that 10 characters. All right, so those are my fields. We have a primary key, which is again the unique way to identify each record here. We have line 1, city, state. All right, don't forget our semicolon at the end. I'm very bad about that. I forget my semicolon often. All right, so I could keep creating tables, but I just want to run this to make sure I don't have any errors, make sure my P-SQL is running. So let's create 2 tables right now. We're going to create students and addresses and see if this works. If it does, great. If it doesn't, we'll need to figure out why. All right, so to run this, easiest way I know how is to type in the P-SQL command. We want to create a database first, probably. So, all right, so I'm going to create a database using the create DB Postgres command, and I'm going to call this school. All right, so data, as Jake and Jack mentioned, when you see nothing in your console, that means it worked. If you see an error message, that means obviously something went wrong. Silence in this case means it's a good thing, so we're good there. All right, we want to run this file. So P-SQL, name of the database, which I called school, and then I'm going to use the caret sign. This basically feeds in whatever file I'm going to give it and run that all the SQL commands from that. So create schema, name of our file. Hit enter. All right, so notice we get some feedback from P-SQL. It looks like tables students did not exist because we created a new database, so that's fine. This is a notice, not an error. Then we created a table. So I'm assuming that both these tables got created. If I do want to inspect it, I could go into the shell. So do P-SQL school. I think \D should tell me a definition. So there we go. So notice that we have an addresses table and a students table created. Additionally, it looks like there's separate sequence tables, and I believe this is how that serial keyword operates, in that the sequence will be maintained by some other table, and that's how we get the unique IDs out of it. Jesse, I think you had your hand raised.
Yes, my question was for the window users probably. I noticed that when I was outside of the, what do we call that?
The shell.
The shell. So outside the shell, I have a hard time doing create DB. So I go into the shell and I do create database to get the same thing. Would that still work, or is maybe there's a better way I can do that on the Windows, or if someone knows a better way outside the shell to create a new class or a new database?
Sure, yeah. Does anyone have any Windows recommendations? Unfortunately, I do not. I know there's I'm looking this up, there might be a create DB command, but Ivan?
Well, what's the error that you're getting?
It usually does not exist, and usually I go into the prompt, the shell in Postgres, and just create a database, and I create it that way, and then I can go out and do everything.
I have a suggestion. Oh, go ahead, Ivan.
I was gonna say it's probably because you have to create the role. Does it say like your name, or does it say root does not exist? Is that like kind of like, okay, so yeah, so basically what you got to do is you got to create a role. I think maybe do it later.
Yeah, yeah.
Okay.
Like
Yeah, that'd be
walk you
fine.
through it.
Yeah, let's take
Thank
this
you.
offline. I was wondering if there's a quick way to do it, but yeah, thanks for offering suggestions. Jesse, maybe reach out in the questions channel and someone should be able to maybe give you what needs to be done. But yeah, all right, so we created 2 tables with our commands. Let's keep going. We have a few more tables to create. Nothing too interesting going on here. We're just trying to get practice with creating tables. So classes, this one seems like a simpler table. It's not what I want. Copy. All right. So we have 3 fields on our classes table. Keep that over there. Same thing. In fact, I'm going to do some copy and paste things to make this a little quicker. So I'm going to drop table if exists. This table that I'm going to create is going to be called classes. And now I want to create table. Put my console down a little bit. Create table, name it classes. Again, we name our tables plural because they have multiple records for that entity. And then we want to specify the fields. Other things to mention, I know Jake and Jack and Raphael probably mentioned this. A white space does not matter. So we can write this all in one line. Like I could do ID, serial, primary key. This is fine. Again, white space, new lines do not matter at all. But it's usually easier to read when you have it on multiple lines. So that's usually why you'll see it that way. Yeah, so I could do it this way. I don't want to, make it hard to read. So I'm going to put it onto new lines. Also, things that have been mentioned, just to reiterate, the case, capitalization or not, does not matter. I prefer making keywords uppercase just to distinguish them and make it clear that those are reserved keywords and not something that I'm specifying. But that is, I guess, dealer's choice. If you want to use lowercase, probably quicker to write. Credits, probably an integer. There's also a small int, I believe. So you can look up data types in Postgres. Small int is just going to be a smaller range. I think might go up to like 65,000 something. But all right. So those are my fields for classes. Nothing too interesting there. So if anyone has any questions, please let me know. But this is what my class table probably should look like. Porfi, you have a question?
Yeah, I was wondering, why not always just use 255 for varchar? Is there like a performance difference there? Or it just seems like it would cover your bases. Unless you want to specifically limit, like I only want 2 letters here.
Right, yeah, I think the last point you said is exactly why you might limit it. So here I picked 10 because if I got a value that had like 20 characters for a zip code, that's probably wrong information. So this is some part of validation where we're like, all right, we know the maximum value that this should have. So zip code, again, good example. If they enter something that's 20 digits wrong, our database should reject it because it's most likely incorrect information. In terms of security, so this is kind of where we go against the grain, where we talk about dry code, where we have, we don't repeat ourselves, and we have a single responsibility principle also, where one piece of our code is responsible for one thing. I'd say data validation / security is actually an exception to that. You actually want multiple layers of data validation. So your database is your last line of defense, as in like this, we should catch, if it's like 20 characters, your database will catch that since we specified varchar 10. But you don't want your database to be the one to check, like be the one checking it all the time. As in this is the failsafe. You should have like your server, whoever's entering in your data into a database or passing the data to your database should check it there and kind of raise an error and prevent calling the database beforehand. So we have multiple layers here. If you're thinking about it, like you might have your front end that has a form. That form should validate the zip code is less than 10 characters. So that's on the UI side. Once that form is submitted to your server, the server should also check and say, all right, is the zip code that I got, less than 10 digits? Is it numeric? All the checks you might want to do. And then the server, if it finds a mistake, should reject and send it back to the front end saying, hey, there's an error in your data. But then also your database would also check that. So we have multiple layers of security because we want our data to be valid. So it's okay to have multiple layers of security. In fact, it's recommended that you have multiple layers of security. Again, on your front end, your back end, anywhere you can kind of add that in.
And just a follow, also the null statements that we had like on some of these.
Oh, yeah.
Yesterday it looked like they were putting them in and putting like no, like null, and then like colon. Yeah.
Excellent point. Yeah, I'm glad you mentioned that. I think that's something I omitted here. So not null, by default, columns are nullable, which means they don't need data inserted. Not null specifies that they must have data. So again, this is another kind of data validation security item where, we should not have an address that has no line. That wouldn't make sense, right? You can't just ship something to Topeka, Kansas, right? I need an address and a city and a state for a valid address. So yeah, not null totally makes sense here. Zip code, you can argue that maybe, if this is Canada, zip codes might not be, I guess they do have zip codes that are formatted different. But we're assuming US addresses here, because we have state. So we're going to make all these not null. Primary keys by default always will be non-null. So you don't need to specify not null here. It's implied when you have a primary key. The rest of these fields by default will be nullable. But if you want to make sure that the user enters valid data or your application stores valid data, that is non-empty, you need to specify non-null. So thank you, Porphy, for reminding me that that's what we want. Yep, we have that for our students. It looks like addresses can be null, so I guess a student can be entered into the system without a valid address. That looks like what the design is. We probably want not null here, because each course needs a name, and then credits, we must have a number of credits that the class has. All right, cool. So that's classes. Thanks again, Porphy. I think that was very important to cover. All right, last thing is enrollments. And we'll do this quickly. So drop table if exists, enrollments, and then create table. I think I've copied columns there. All right, create table, enrollments. Again, if I'm going too quickly, if you guys have any questions, please ask, because this is the great time to do so. We have an ID, serial. This is a primary key. Again, the unique identifier for our table records. And then we have a student ID. Kat, you have a question.
Yeah, I was just wondering, I know here we're doing all primary keys for every table, but I've seen like tables have just a foreign key. Is there ever a reason where you wouldn't give a table a primary key?
Based on my knowledge for relational databases, I'm going to say every table you create should have a primary key. Now, it's possible to create like a table without a primary key, but I'm going to say that's bad design. And I'm not going to say that's just my opinion. There might be exceptions to that. But for our purposes, let's just say every table you create should have a primary key. You can have foreign keys in addition to that, but primary keys are a must for relational databases. Not null. And grade. This is probably a varchar. I'm guessing it's going to be like A plus, B minus. I don't think we're going to exceed 2 characters. So I'm going to make that varchar 2. All right, so that's what our enrollment table is going to look like. I spelled it correctly. All right, enrollments, ID, student ID, class ID, grade. Okay, I'm going to run all these commands. I forgot my semicolon, like I said I would, right there. Sql school. Let's give this a run and see if we have any errors. Create schema. So again, psql command, name of my database, I guess less than sign, and then the file I want to run for SQL. So it's going to run all these SQL commands one by one in order, top down. Order doesn't matter there. So we hit enter. Okay, so let's read the summary because we're getting some information out. Looks like some tables were dropped. So notice that I get 2 drop tables without any notices. That's because we ran this query once before and we created a students table. So this drop statement actually dropped that table. So this dropped the students table, this dropped the addresses table. Those were my first 2 tables dropped and created. The rest of my tables, notice I got a warning or some information saying, hey, this table never existed, so nothing happened. All right, that's fine, not a big deal. Okay, so I think that creates our tables. I think step 2 is testing our schema. So before we load some C data, log into Postgres. All right, we can check to make sure we got the fields we want. Let's follow the guide here. So psql school. I'm going to do \d. Let's investigate our classes table. All right, so notice that we get information about what our class table structure looks like. Our ID field is integer. Our name is up to 64 characters. Notice all these are not null. So again, for our classes table, just to reiterate, we had a primary key, and a primary key by default is going to be not null. That is something I didn't specify. Primary key just has that built into it. A primary key can never be null in a table. Okay, so that's the structure of my classes table. We can go through each table, but I don't think it's gonna be anything too surprising. Just kind of understand that you can use psql to kind of investigate your structures. \d, I think stands for definition, and you can specify which table you want to kind of look into. Looks like it tells us the name of the primary key it created. Also looks like this is how it gets the next value. There's some function it's calling into the classes ID sequence table. So again, a lot going on behind the scenes, but for our purposes, ID is going to be auto-generated. If we want name and credits, we're going to specify the correct types for it. I saw a hand raise there.
I had a question about the primary key.
Sure.
So if you delete something later and you rerun it, then it'll drop, then like it'll -1 from like the primary key, right? And give everything else a new primary key.
If you remove a record, you're saying?
Yep. Like from like the middle of the thing, like
No, it will not minus it. So it's just gonna take the next value in the sequence. It's not gonna backfill in the sequence values.
Okay.
Yep. If you drop your entire table, then it will restart from 0 or start from 1 because databases are 1 base, not 0 base. But no, it's not gonna fill in those gaps. Good question though. I think it just keeps counting up and up and up from the last record. All right, so I'm not going to investigate every table here. \Q should get me out of my shell here. All right. So I think our tables look good enough for now. We're probably going to talk about student ID and class ID later on in our lecture. But right now, I've just made them integer fields that are not null. Ideally, these should actually be foreign keys, but I don't think we've talked about foreign keys enough to sneak that in here. We should be able to get by this challenge without that. Okay, so that is completed. We checked out some tables, inserting data. So if our schema looks correct, try running the included cdata.sql using psql. So let's take a look at what cdata has in it. These are insert statements. So this is how we actually insert data into tables, insert into table name, the columns we are targeting, and the values that we are targeting. Notice in this case, we are actually specifying the ID. We don't have to, right? Because the serial keyword will automatically increment for us. But in this case, we specifically want 1, 2, 3, and 4. If we didn't specify the IDs, they might kind of keep counting up as we delete records and then add more in. So we're explicitly saying we want IDs 1, 2, 3, and 4 instead of letting the serial counter decide for us. But it looks like we're inserting data into the addresses, students, classes table, and then a bunch of enrollments. And I think that's gonna be for our sequence. Yeah. All right. So let's give this a run. I'm just gonna, I don't need to modify this. I'm gonna run psql Sql c data, and it gives us some summary. So it did a bunch of inserts. Looks like 4 rows into the addresses table, 5 into our students table. Yeah. So again, nothing too detailed, but gives you some summary of what it did. Yelan, I think you had your hand raised.
Yes, thank you. Just curious, so if you give it a serial number yourself, will the system take yours instead of the auto-generated?
That's a good question. So it looks like there's some adjustment being done here to the sequence tables where we're saying pick the max ID and then make that the next sequence. It's a good question. We could try to test it out. Sure, I'm going to try to test it out if you guys don't mind a quick tangent. So if I insert a new record down here, let's pick value 5. And the question is, if I try to insert another one after that, will it take value 5 or will it be 6? I'm not sure. So let's leave this off here. I think default is the keyword I want, or leave that off. All right, so we enter 2 new addresses into the addresses table. It's going to be address 6 or address 5, and this is going to be address 6. I'm just going to put those at the street lines. I'll keep these the same. Let's change this. Fine. Let's go Chicago. Some street. Okay, so hopefully this will tell us if this is going to work. So let me uncomment or comment all this out. We want to insert 2 new records. One's going to specify the ID ourselves. The second one is not specifying the ID. We're going to rely on the sequence. Let's see if this works. If it doesn't, then it doesn't. I'm going to say it's probably not going to work, but let's find out. It doesn't hurt to try. So I'm going to do psql school database, feed it c data. Yep, there we go. So we got a duplicate error. So duplicate key violates unique constraint. So it looks like the sequence table Again, does that work for us? If we do not rely on the default, we need to make sure the sequence table gets updated. So here we inserted 5, but the sequence table for addresses ID sequence is still thinking 5 is going to be the next ID. So it's not that smart to kind of know automatically. Either we use serial and let everything work behind the scenes, or we specify it and then kind of tinker with the sequence table that is behind the scenes. That's a good question. Yep, good question. I know that was, yeah, it's an interesting question. I wasn't sure what I was going to do, but yeah, I think based on what I've seen, pretty sure that was going to yell at us, and it did. All right, so we got data in our table. If we want to prove that, we can run some commands. So let's go to pSQL. We can run commands in here. So I could do, oops. I want to run pSQL school database. So notice I'm in my school database now. Let's run a command. Let's do select star from students, semicolon. And if this works correctly, we should see 5 students listed, right? We inserted 5 students, Tiana, Elda, Jed, Leopold, and Andre. There we go. So it looks like we have IDs here. Leopold does not have an address ID, but that's fine. That's not required. We allowed that field to be null. All right, so it looks like our data is in our database. We could check our other tables, but I'm going to assume they all got in there. Okay, I think that accomplishes our SQL basics, where we created some tables, inserted data to make sure everything was right with our schema. And I think we're good to go here. Any questions about any of the steps we took, about creating tables, any of the commands, keywords that you saw that were new? Definitely ask, because we want to make sure you're comfortable with using SQL. We got some hands raised. Let's go with Jesse.
Yes, on the seed data one at the very bottom, it talks about the select set val. Is that a new variable that you're creating, and how is that working? That seems a little bit different for me.
Sure. I'll be honest, I do not 100% know what set val does. I've never used it, like wrote set val or used a set val function, but looking at this and just kind of guesstimating or guessing based on what I know, it's going to be setting a particular value in this table. Let's actually maybe take a look at this table to make sure we know what's in it. So I'm going to do pSQL school database again, to \d. So let's take a look at the addresses ID sequence table and just see what's in there. I'm going to assume it's 1 value, but never hurts to check. So let's do \d. Yeah, so notice it's just 1 value. It tells you what the maximum value can be. So it looks like it goes up to like 200 or 2 billion. So it goes up by 1, tells you where it starts at. I'm not sure where it tells you the next sequence ID though. But again, I assume this function is just it's setting some value somewhere. I actually don't know where, but that's my guess here.
So just so like with our assessment and all that, we'll just have to remember to put those pieces at the end of our seed data, so we would have that automatically for each of the sequences in our tables.
Yeah, good question. So I would recommend that you don't mess with the sequence tables. Again, I've never done this. This is again kind of something that is foreign to me. I would say rely on this. If you use the serial keyword, just don't specify ID. You can insert values this way, and now this is going to automatically take the next ID available instead of hard coding the ID that you want.
All right, thank you.
Yep. Jin?
Yeah, so for the drop table statements there, in the future when we're working on our challenges or something, should we always have things like that when we're creating our tables?
I'm gonna say yes, try to make it a good practice, because again, if we didn't have this, like let's say I commented this out and I want to rerun my schema, well, I'm gonna have to either manually go and drop my tables beforehand or drop my database and then recreate it. That's not always ideal, even though it's not too difficult. But if I do run the schema file, pSQL school, and then feed it, create schema, now it's gonna try to create this table that already exists. So notice you get an error. That's probably fine. Like it's still gonna create the rest of the tables. It doesn't stop doing what it's for the other commands it wants to run. But again, you want to try to avoid having errors from any queries you write. So dropping the table is probably recommended. However, with that said, if you successfully do not want tables to be recreated, as in if I have a students table that has data in it, maybe I don't want to lose that data. Dropping the table will remove all the data I have stored in there. So this isn't necessarily something you have to have. It's your decision. If you want to drop tables and recreate them all the time, or if you want to kind of have that protection of, if I have a table, don't recreate it. Well, that's fine. Just take away the drop table command. I usually just create them because my schema files, I run them kind of multiple times as I tinker with them. So I rather just have that done for me.
Thank you.
John.
So it's kind of more of a comment for your C data. I know you had mentioned not putting in the key in there, but if you're working with relational tables and you don't specify that, you're never going to know the order. And I ran into this when I was creating my blog. So when you see the data, it won't match up properly between your foreign keys. So that's the reason why you'll see C data where it specifies it, and then at the end it'll set the new seed increment.
Yeah. So for our C data here, we are kind of, we are implicitly saying there are foreign key relationships, meaning our students table says ID 4 right here. That is referring to ID 4 from the addresses table. So that's why we are hard coding. Like we want this address to be ID 4. Again, we don't want that auto generated because we might not match the correct thing by putting 4 here. Again, we don't have foreign keys in play right now. That's something we're going to add in later today. But the idea here is that we should have some relationship between our students table and our addresses table. We do not have that relationship right now. We are kind of assuming there's a relationship without actually telling our database that there is a relationship. All right, any other questions about SQL basics? Hopefully you guys were able to get through this and understood kind of getting more familiar with the commands for creating tables and how to specify data types. Again, additional constraints. So this is saying you must enter a value. This is saying, maximum 64 characters. So there's some built-in validation when we create our tables. Okay. What questions do you guys have? All right, if there are no questions, we can do git add, git commits, completed basics, and git push origin. All right, so we have another challenge, and we're just going to continue on because it's related to this challenge. We have Sql Queries. If you guys are okay with it, I'm just going to kind of continue this challenge in my SQL basics repository. But we have a bunch of queries we're going to run on our data, on our database that we just created that has some seed data. So let's create a new file. I'm going to call this queries. Again, these are just names I'm choosing. There are not any standard default naming queries. And then these are all the queries we want to create. All right, so a bunch of them. Some are maybe a little easier than others, but let's see how we do with them. All right, I'll enter those later. But this is where I'm going to ask for some student help because I want to hear what you guys came up with for these solutions. Let's go to my randomized list. All right, so let me randomize. Okay, so Brendan Dotree, could you help me with this first query that we want to write here? Select all rows from the classes table. I'm not sure if split screen will be helpful, but let's try it. Split screen, create schema. Okay, so this is what our structures look like. We have the classes table. Brendan, how can we select all rows from the classes table that we created? We have Brendan online. All right, Brendan might be away. John Price, could you help me out here?
Yeah, it will just be select asterisk from classes, semicolon.
Sure. Can you tell me what the asterisk does, just so we're clear on that?
The asterisk selects everything within in the table, or I guess it would select the entire row more specifically.
Yep. So this selects basically all columns or all fields, whatever you want to call it, within the table. So in this case, we have 3 fields. We have ID, name, and credits. The asterisk, as John said correctly, it's going to basically select all of those for us. We don't need to specify, each one by one, especially if you had like a table with 100 different columns. It's going to be tedious to write all those out. So the star makes it kind of easier to access all the columns. But yeah, so we're saying select all the columns from the table that we specified. In this case, it's the table classes, which we created. So let's give that a run and see how that goes. New pSQL, school, and then the new file I've created is queries.sql. That's going to run this file. We only have one command that we're going to run. Let's see what the output is. All right, there we go. We are missing data. Is it? Oh, because I reran my schema. That's my bad. I need to run my seed data file again because I dropped my table and recreated it. So let's do seed data. Okay. Now we should run our queries file. So we do pSQL Sql Queries, and hopefully we have data in our database now. There we go. So notice that we get all the fields. We get ID, name, and credits, and we get the data inside the table. All right, so pretty straightforward there. But again, if you have any questions, please stop us at any point. Let's keep going. So select the name and credits from the class table where the number of credits is greater than 3. Jidan, could you help me with this, please?
Yes.
Okay.
Okay, so you just select.
Okay.
And then select name.
Yeah.
And then credit.
Yep. So we separate column names with a comma. We want credits, which is another field. Yep.
And then from
classes.
From classes. Yep. And then is it where?
Yep, the where keyword. That's our filter here. And what do we need to, what's our condition that we want for these records?
So the condition is where the number of credit is greater than 3.
Yep, greater than 3. So we could do a simple greater than operator.
Mhm.
Yep, so this looks correct. So again, we are specifying now which fields we want an output because that's part of our requirements. We don't want every field. The requirements say name and credits only from the classes table. And then the where clause, again, this is our filter. It's not going to give us every record back. Our first query give us every record because we didn't specify any filtering. The where will say, all right, only records that have fulfilled this condition, in this case where credits is greater than 3. Looking at our previous output, I would expect that CS 101 and physics 218 should be the only record returned because those are the only records that have credits greater than 3. So let's verify that. I'm going to keep running our queries file. And there we go. So notice that we only have 2 fields displayed. So the ID is not displayed, unlike before. We have name and credits because that's exactly what we specified to select. And then the records that match the given criteria. Here, credits greater than 3. And yep, both of these credit values are greater than 3.
So do we need a semicolon at the end?
Yes.
After?
In this case, it works. I had one command, but yeah, I'm really bad with the semicolons here. So hopefully you guys are better than I am. But yes, this will separate multiple commands. So if I had this command and that command without the semicolon, I'd get into some trouble.
Okay.
Yep. But in this case, I got lucky because I had one command. So pSQL knew that's the only thing I wanted to run. Okay, cool. Thanks, Jidan. Let's keep going. Marcin, can you help me with the next one? All rows from the classes table where the credits is an even number.
Yeah, I would select, start with select. So all rows, so select asterisks from classes where credits modulo 2 and even numbers so equals 0.
Yep. That seems correct to me. Important thing to remember, there's no double equals in SQL. Again, I'll use myself as an example. I oftentimes accidentally write double equals and then SQL yells at me. We use single equals for comparison in SQL for whatever reason. That's the SQL designers created that. So let's run that. I need my semicolon. Comment this out. All right, there we go. So notice we get 4, 4, and 2. These are even number credits. We don't have any odd numbers. So I think Marston's query here is correct. Good job, Marston. Let's keep powering through. We got a bunch of queries to go through. We might skip some here, but let's see how we're doing on time. Let's go with Marcos. Marcos, can you help me with this one? All of Tiana's enrollments that she hasn't yet received a grade for.
Yeah, can you scroll down on the table or on the schema a little bit?
Oh, yeah. So I don't know how to fit all this in. Let's go with enrollments first.
So I believe how I did this one was I looked at Tiana's ID or whatever.
Yep, that's fair.
That way I could hard code that in.
Yeah, that's fair. So we could look that up in, I guess, a lot of databases, school. So we look at the students table. I think this is fine based on the question that is after it, but Tiana, her ID is 1. So we can kind of hard code that. So that's fair. Let's do a select. And how do we get information we want here, Marcus?
Select star, then from enrollments, where student ID equals 1.
Yep, I think that is what this challenge is asking for. So we know Tiana's ID, we're taking that for granted.
And I think there's an and statement in there too, because it says where she hasn't received a grade yet. I think I just went and grade equals an empty string.
Yep.
I'm not sure, you might be able to use null there though, but I don't remember.
Yeah, so that's a good question. In this case, I'm going to assume that if the grade has not been entered, it's going to be null. Because notice for our schema design, we specify that it is allowed to be null, right? We don't have a not null constraint here. So I'm going to assume they don't have a grade. It's going to be a null value, not an empty string. Now that could come down to how we actually implement our application. What I'm going to check is null here because that value, let's actually check our seed data. That's probably the best way to go. So if I go to my seed data, let's see what they enter in. Notice that some of these records have null. So empty string would not match that. We want to check for is null. Let's make sure that I'm not mistaking that. So empty string versus null. Marcus, does this work for you with empty string? Just want to make sure.
Yeah, I'm pretty sure it did. I don't know. This was the challenge we did Monday. So
okay. Yeah, let's try it both ways actually. So is null is going to actually look for null values. Let's see what our output is. We only got 1. That seems wrong. Oh, for Tiana only. So seed data, Tiana, she had 2 records. Only one of them is null. So that looks correct. Let's see if Marcos said we tried empty string. So we said equal to empty string. Again, remember, use single quotes, not double quotes. I'm terrible about that as well. But double quotes in SQL mean something else. So here, empty string. Let's see if this works. All right, so this did not work for me. So Marcos, I might ask you later on maybe how that worked for you. But in this case, again, null and empty string are not the same thing. So notice we got 0 rows returned here, even though Tiana has a record with no grade. So it looks like null, we need to explicitly be checking for null. Empty string is not going to cut it here. So grade is null. We could probably do equals null, but is more correct because this is an identity. Null is one value. It's like saying, is this something? It's not equal to it. I feel like I'm mincing words here, but you can use both. You could use equals null, should work the same. I guess it does not, sorry. Is null is what you use to compare against null. Yeah, there we go. So is null, not equals null. I guess I thought both of those would work, but I stand corrected. So is null is how you compare against null, not equal to null. All right, let's go to the next one. This one should be pretty similar, so I'm going to copy paste. But there's an added challenge here. So notice that this question asks, you cannot use Tiana's student ID, you need to use her first name. So this is not going to cut it because we can't use student ID per the requirements. So Courtney, how would we solve this similar query given the additional requirements here?
Select all, the select asterisks.
Yep.
And then from let's see. I'm sorry, am I going off of the students table right now? Can I see the I was thinking it would be from enrollments.
Yep. Yeah, so we want to have enrollments involved because that is how we check the grade. But in this case, we also need to have some way to access our students table. Do you remember how we can kind of tie the students table in here?
I don't remember.
That's cool. No, that's totally fine. So this is where we're going to use the join keyword. So the join keyword is going to kind of combine two tables together behind the scenes. And so we say join students, and then we use on, and we got to tell it how to match records in this case. So we have enrollments. For every record in enrollments, we want to tie it to some student record in the students table. So we use join students on, and we create a match. So we do students dot ID equals, again, it's single equals here, but we're comparing enrollments dot students ID. So we're saying effectively for all the records in our enrollments table, any record that has a student ID that matches an ID in the students table, we want to combine those into a single record. So it's going to be basically a student's record and enrollments record on the same line in this kind of joined imaginary table behind the scenes. So it's going to match based on these two values. And then we want to say by first name. So our where clause, instead of saying student ID equals 1, we're going to do first name equals Tiana. Right. So now we have access to first name from our students table because that is now joined with our original enrollment table that we're going to looking through. So again, this join creates kind of an imaginary table that has a student record and an enrollment record on the same line. And that is, they are matched by this condition. So it's saying any record, again, in the enrollment table that has a student ID that matches an ID in the students table, well, that becomes one new record for this join command. Grade is still going to be not null, but in this case it's first name. So let's see if this works. Clear. All right, there we go. So notice this is basically a combination of the enrollments table, which is ID, student ID, class ID, and grade. What I've highlighted here is part of the enrollments table. What I've highlighted here is part of the students table. Notice that they're just kind of merged together. And that's what the join command is doing here. It gives you access to both tables. So grade here is coming from enrollments and students is coming from first name. Now, this is something I personally do. This is, I guess, optional in some cases, but it's not super clear to me that first name is in the students table and grade is in the enrollment table. In this case, it works as those are uniquely named columns or fields in each table. But technically, you could have a grade column in either, like in the students and in the enrollment table. There's no law or no rule in databases that says you can not use the same name column in different tables. But in this case, what if I want to be more explicit? This is where we can use aliasing to kind of give our tables kind of variable names. So in this case, I'm going to put a capital E after this. This is basically, if you want to imagine like a variable I'm creating that's named letter E. I use uppercase single letters for variables, but you can call this, enroll. That would be your variable now. I'm going to use single letters because they're easier to type. It's all about speed, right? So single letter, gonna be easier to type. You could argue lowercase is probably faster to type. When we go capital E here, so now I'm saying enrollments is gonna be referred to as the variable E. So E is gonna refer to the enrollments table. I'm gonna say S is gonna be my students table. And so now this kind of shortens what I need to write here. So I can do s.id, e.student ID. And now I could also specify s.first name, e.grade. Right, so this will let me easily identify, all right, this is coming from the students table. Again, I don't need aliasing to this. I could do this without aliasing, but it requires more typing, right? So I go back to what I had before, students and enrollments. I could enter in students here to be more explicit, but again, this is a lot more typing. Aliasing will make it a little more manageable. So this would work too. What did I screw up here? Enrollments. Yep, made typos. That happens with longer names. All right, so we get the same result. This is more explicit, but optional, but recommended, I guess. A lot of caveats there. I saw some hands raised. Kat, you have a question?
Sorry, I think I probably figured it out, but I was just wondering, you might have already said this, for the enrollments table for grade, did you use varchar 2, like in case there was a plus or minus or something
Yeah,
instead of 1?
Yep.
Okay.
That's what I was assuming was going to be in there. I mean, I guess you could maybe think it could be a grade point average, but I think our seed data had, yeah, I guess they don't have pluses or minuses, but I'm assuming you give a, A+ for great work. So yeah, I made mine varchar 2. Shun, did you have a question?
Yeah, so when you set an alias like that, you can use it for like the next select statements thereafter, right? Or
If I run a different command?
right.
No,
Or
so
you have
it's
to set it every time.
no, yeah, it's only going to be for this command. It's not going to carry over to any other command. So it's not really like a variable. It's like an internal variable. If you want to, again, this is a far stretch, but imagine this is a function. You create a local variable only accessible to that function if we're trying to use like Python speak, but it's an alias that's accessible only for this query and not any other queries.
Thank you.
Yep. You might see occasionally at the as keyword. This is sometimes required, but in this case, you don't need the as keyword to create an alias, but it's more explicit, I guess. In this case, you're saying exactly what it is. So I don't think it makes a difference using the as keyword or not. So usually I leave them off because they're requires less typing. John Price.
Hey, yeah, can you go over the join statement one more time?
Absolutely. So joins are complicated, so definitely require some time here. So we're saying we want to select something from the enrollment table. So without that, if we had a command like this, we're saying go through each field of the enrollments table and then apply some condition to it. Now the issue here is that we don't have first name as part of our enrollments table. That first name does not exist within our table, so we cannot check students.first name equals Tiana, even though that is something we ultimately need to do, selected by our first name per the requirements. So this is where we need to kind of loop in a different table. And that other table is where first name exists. In this case, since we want to access the first name, we need to loop in our students table somehow. And that somehow is via that join statement, which is, we say, all right, we want to loop in our students table. So that's what join students is going to say. Hey, students table, please come into the mix here. But then the important thing here is we need to tell this query how to match up records from this table to this table. There's no automatic way that it knows how. There's no default way. So we need to tell it, hey, as we're kind of creating records for this kind of joined table here, we need some matching criteria between records in this table and records in this table. To achieve that, we put the on keyword and then create some condition here. So it's not going to be in our where clause. Our where clause is for our select statement. Our on clause is for our join statement. So the on clause is some condition where we say, all right, how do we match records from this table? Right, we have ID, student ID, class ID, and grade. How do we match a record from this table to a record in this table? And so we need to kind of think about it. Well, what's the kind of unifying column here? In this case, it's student ID, right? This student ID should refer to the ID in my students table, because that's how our data is kind of segregated, right? Students has all the student information with a unique ID that we can refer to. And then this student ID should be pointing to some student in that table. So to match that up, we'll say enrollments, or you can do it either way, but I'll say students.id needs to match the enrollments.student ID. Now, common mistakes I've seen, sometimes, again, just typing and not really understanding the structure. I've seen this before, maybe I've probably done this before too, where you say, all right, students ID needs to match enrollments ID. This is not going to give you what you want, because this is going to match the primary key of enrollments with the primary key of students. That's not really sensible. That's saying, all right, if this is the 7th enrollment, well, that matches the 7th student. Like, that's not kind of how our data works right now. So in this case, again, make sure you're specifying the correct fields. In this case, we want to match the student ID field with the primary key from the students table, because that is how those are linked, or should be linked together. And now once we create that match, there's this like imaginary table that gets created that has records from the original table, which is enrollments. Notice we have ID, student ID, class ID, grade, and the student's ID. So right here, all these fields are from the student field, or sorry, student table. In this case, notice that the ID here from the students table always is going to match the student ID from the enrollments table. If you want to see this a little more clearly, let me take out the where statements or where clause. Let's just run this without any filtering. Notice what we get here with just our join statements. We're doing select everything from enrollments with this join. We get a new table, like a new temporary table that has the combined records. So notice that student ID is always going to match the ID from the students table, right? So this column right here always matches this column, because that's what we exactly told it to do. That's how it matches them up. John Price, did that clear anything up, or do we need to explore that a little bit more?
No, that's very helpful. Thank you. Yeah. So just so I'm completely clear. So your where statement acts on the new table created from the join statement.
Correct. Yeah.
Cool.
Yeah. So it's kind of like if I highlight these two together, this happens together, where the on says, all right, enrollments and students, let me marry you together. And then, yeah, the where clause applies to the select, not to anything that's happening right here. Okay, good question. Again, joins do get complicated, so definitely spend time on them, practice them. Again, if you didn't complete the tutorials yesterday, SQL Zoo and the Postgres tutorials, definitely go through the join section, because hint, 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 or not really a hint, it's going to be part of your assessment. So make sure you can do queries with joins, and sometimes multiple joins, because that is something that is basic enough that we should understand. Andrew.
I think you talked about it a little bit earlier, but you don't even have to put, you can just do like join students on ID equals student ID, where first name equals Tiana and grade is null, because like the same column value isn't in both of them, right?
Well, in this case, it is. Notice that every table has an ID field. So if I left ID here, it's going to be ambiguous. This could be referred to the enrollments table or to the students table. There's no ordering here. In fact, like I could do this the opposite way, where students.id, again, the on clause does not assume that your students table is referred to first and enrollment.
I see.
Yep.
Because
so if I did ID
it
here,
is in both.
Yeah, let's try it and let's see what happens. Like maybe it'll yell at us, maybe I don't know what's going to happen, but it should tell us an error, because SQL is not smart enough to know, like, okay, you want to match one table from another. It's just trying to match some columns that we're telling it. In this case, it's probably going to be unable to do it. Yep. Notice column ID is ambiguous, because both our student table has ID and our enrollments table has ID.
But you could do it for the first name and grade, right?
Correct. Yes. So yeah, the first time I did it, you can do this because SQL knows which columns we're talking about, because they're unique between the tables. That works. Oops. Yeah, so that worked, but I like being more explicit, so I'm always create those aliases and kind of specify which tables, just to be more clear. Sukhdev.
Hi, good morning. If we didn't want in the join table to have like duplication between, like, say, the ID and the ID or one of these things. Is there a quick way to do that? I saw that we could like write out all the columns we wanted, but it just seemed pretty verbose.
Good question. I know, let's try inner join. That didn't change anything. The question is, how do we merge this and this column?
A left join might do it, but I think too, when you do like a left join, it'll match the rows, but also when it pulls in the other, and also you have the opportunity to have more null values doing it that way.
Yeah, again, join's a little more complicated, so I think the default is a outer join. There's inner join, left join. It's an inner join. Yeah, so there's left join, right join, inner join, outer joins. Again, they get a little more complicated. I just use join. That's good enough for my needs. But you can specify more. Again, left and right joins will kind of say if there's no match, still add that record into your matching table.
Hey, Ankur, can I make a suggestion real quick here?
Yep.
So if we want to disambiguate the ID in the output, can we be more specific in the select statement? So can you try enrollments.star, comma, students.star?
I'll change the headings, right? So
That's my intention.
We
does
can
not seem to have worked how I thought it would.
We can give them names. So I think it is possible to do something like, it's a little more tedious. Let's see if we can achieve this. So if we want to do enrollments.id, we got to kind of write out what we want. Let's do aliasing here. Sorry, we're getting maybe a little off the track here, and we do have more queries to write, so we'll try to get past this in a second. But yeah, we can rename the output here if that's the question. Like in this case, we have two fields ID. It might be kind of confusing. So I could say I think let's call it EID. I think that should work. Student ID, class ID. All right. E.grade. S.id as stud ID, and then S.first name, S.last name. So again, it gets a little tedious when you gotta write out like 20 columns. That's why the star operator is really great. S.birth date and S.address ID. Let's see if this works.
You forgot the dot on line 27.
Good catch. 27 E.grade. All right. Hopefully this achieves what we want. Yeah, there we go. So you can rename the columns that get output as notice. Now we have EID and stud ID, so we can kind of distinguish them. A little tedious, usually not necessary, but you can kind of rename those. I don't know if this addressed Sukdev's main question was, Sukdev, you wanted to kind of combine, was it like you want to combine student ID here with stud ID because they are the same thing? Was that the original question?
Yeah, and I guess, I mean, the way I had done it is I just had removed it from the select, I think.
Yeah, so in this case,
And, yeah,
we
so I
could
was just
do that,
wondering
yeah.
if we could do it without writing it all out.
I don't know of a way. So in this case, yeah, we're just omitting it. So now we just have one student ID. So a little less data in our select statement. I don't know of an automatic way to do it. I'm not gonna 100% say there's no way to do it, but aside from writing it out and specifying exactly what you want in the output, I'm not sure if there's a easier way to do it.
Okay, thank you.
Let's move on. We have a few more queries. In interest of time, let's kind of skip a few here. Let's do average number of credits for classes offered in the school. Let's go with Changil.
Yeah, probably do select AVG for the average.
Yep, AVG
And
is a
then-
built-in function.
Yep, and then put the credits there.
Okay.
And from classes.
Okay, so again, this is a built-in function. Let's see if this achieves what we want. So I need to comment. I did comment it out. Clear. Run our command again. All right, so notice 3.2. That's probably right. You know, we could do some quick math for 4 + 4 + 3 +. Yeah, I'm going to assume that's correct. So again, average is a built-in function. There's a few built-in functions that you can take advantage of. Let's see, maybe one else we could use. How about the total number of credits? Let's do this one. Total number of credits each student has received a grade for. Let's go with Jenny Lee. Do you have a query that might satisfy this?
Select.
Okay.
I put like sum.
Yep, so sum is another built-in function. Again, there's no way to know this magically aside from reading documentation. So if you're like, hey, where's this coming from? Most likely you got to read documentation or see examples to understand what functions exist. All right, sum.
Some credits. And then first name from students. Join enrollments. On
Go on
students.id equal enrollment student ID.
Yep. So again, we're matching records from two different tables for our join statement. I created an alias here just to make my typing a little easier. All right, do we need anything else for Jenny Lee?
I added another join classes.
Yep, so we're using multiple joins, totally allowed here.
On enrollments class ID equal classes.id.
Yep. So again, I'm using alias here. So I'm writing C, E, and S to stand for the tables. Yep, this looks correct. So again, we have a join statement combining our student table and enrollment table because we need to match, students are enrolled in classes and the enrollment table tell us which classes. So we are further bringing in the classes table to say, all right, well, we need to figure out what class, let's see. Well, do we need classes in this case? I'm trying to think here. I think we might not need classes here, but again, it's not going to hurt us. Do we need anything else here, Jenny Lee?
Group by first name.
Okay.
That's it.
Okay, I think we might need one more because only grades they have received. So this will be all enrollments, even grades they haven't received. So we might need a having clause here. Let's see, having E dot grade is not null. This one definitely gets more complicated. I think we don't need our classes table here, so I'm going to remove that because we only care about enrollments and students. Again, I don't think we need, oh no, we do need it. Sorry, you're right. That's my mistake. Credits is coming from classes, not enrollments. Sorry, Jenny Lee, you were totally correct. So credits, make sure I understand my structure here. Credits exist in our classes table. Our first name exists on our student table, and that is kind of combined with our enrollments table. So here we need three tables. Jenny Lee was totally correct. Classes gives us the credits. Students gives us the first name, and we need to group for every student here. And the grade is coming from the enrollments table. So again, a lot going on here. I think having is going to affect our group by. Let's take a look at this. So I need my semicolon. See if this works. E grade must appear in the group by clause. Right, so if we do it without this, this is not going to be our full objective. All right, so this is the number of credits they have taken, but again, the additional requirement is receive a grade for. So if we look at Leopold, Leopold is ID, let's see, Leopold is ID 4. Looks like Leopold has not received grades in a bunch of classes. So he's enrolled in a bunch of classes, but it should not be 18 here. So we need to figure out how to trim this down. I want to say it's having, but
I used the where for this one. And it
so
works.
where E dot grade
Is not null.
is not. No, okay, so where is gonna affect the select? Having affects the group by.
Where before the group by, I don't know if that matters.
Let's find out. All right. Syntax there. Okay, there we go. So notice Leopold got cut down to 8 because he had a bunch of classes where he does not have a grade. So I'm going to assume 8's correct. Thank you for adding that here. So it looks like the where clause, we want to use the where clause. Having, again, affects the grouping. I'm trying to recall how the having clause works. So having would be, let's say, having s dot first name. I like, let's say they have an A in their name. Yeah, so we do, I like A. Let's try to find, let's see if this removes Leopold. So on this. All right, so yeah, having, again, we haven't covered having too much. Maybe I shouldn't spend too much time on it. The having filters down your group by. So in this case, we're saying we want to group by student first name. But the having says only students that have an A in their name. So these two kind of work in conjunction. The where clause affects our select statement. So yeah, in this case, the where is not going to affect each individual group. It's the records that we get returned for this summation. So every class that is matched with enrollment that has a grade is used in this sum here. Again, so it gets really tricky. This is definitely a more complicated query. We don't need the having here though. The where clause here achieves the full part of this. Okay, I think I'm going to wrap up here because we do need a lecture to get to. But again, definitely some more advanced queries. This one, make sure you understand the idea of joining multiple tables. So in this case, generally, thank you very much. We need to join 3 tables because we need information from all 3 tables. We need credits from the class table, first name from the students table, and the grade from the enrollments table. Joseph?
Later on, at stand down, you have a check on line 36, says more than one word. Can we go over that one?
Yeah, we can do this quickly if you want. Select students and their addresses. So do select star from students, join addresses, right? Because that's where the addresses information is. Let's call that A. Let's call this S. On, and now we need to match our student.address ID with our A.ID, right? That's how we link up tables here. And now we just need a where clause. So I think the simplest way to do this would be A.city. I like, or we don't even need insensitive like, but that's fine. And I would just look for a space, right? So if there's a space, I'm going to assume there's multiple words. That's assumption I'm taking. You probably don't have like, Chicago and then random spaces at the end. I'm going to say if there's a space somewhere there, then that's going to achieve that for me. So again, we're combining 2 tables via the join keyword, and we're going to look for a city that has a space in it. That's going to tell me that's more than one word.
How does it recognize the space if it doesn't care about white spaces?
So the text, again, this is a string. So the string, the white space does matter.
Oh,
when
that's
we say
right. Gotcha.
The white space doesn't matter, it means if I put a bunch of white space in my query, this is going to work just the same. So these white spaces do not matter for the query, but for strings, again, spaces do count as characters.
Thank you.
Yep. Roque?
Yeah, can we just quickly go over line 933? I had a lot of trouble with that.
Sure. Average age of all students. So we're going to do select. ABG is a built-in function. Let's do, I think there's an age function. So again, some of this comes from documentation. I know it's like coming out of thin air. There's an age function. Current date is a reserved keyword for the current time in Postgres. So we do age. and then the birth date. So we'll do s.birth date. So again, a lot going on here. A lot of it coming from documentation. The age function will take two dates, in this case, the current date and the birth date that's stored, give you the age from there. And then the average function is going to average all those ages that we get. So if I do from students, that might just be it. So let's do I have any other commands here? All right, so let's run that and let's see what we get. I want this here. Comment that out. All right, try that again. Oops, I didn't alias my table. So again, you can't use aliasing without creating that variable. So there we go. So we're saying, again, this is a built-in function, nothing I've created. The age function will take in two dates, give you the age or the separation between those two dates, and then the average will, again, give you the average for each entry we get. So in this case, the average age is 34 years, 11 months, and 10 days, looks like. I guess some time change left over. So again, a lot of built-in functions you can take advantage of. There's count, there's average, there's sum, there's min and max, I believe. So definitely do your research and documentation. I know that's not the most glamorous thing to do, but that's the only way to kind of learn about what's offered to us. Okay, I'm going to wrap up here. Definitely thank you everyone for helping us out here.